Okay, well, our first test here is going to be a control.
Aerospace engineer Steve Harrington has made a model of a USO, and we're experimenting with different ways to reduce the splash of the craft as it plunges into the water.
3, 2, 1.
Whoa, that was a lot bigger than I expected.
That was a splash.
That was a splash, all right. I'm very surprised that an object this small creates such a big splash. Every USO report that we've received describes a large object entering the water without a splash.
They appeared to be just beneath the water. They started vibrating, but the water wasn't moving.
We think we have an idea of how this is possible.
So here we have a hose with compressed air going into a tank that we saw before, and then we have all the little nozzles out front where the air is going to be jetting out. Okay, air pressure on.
Oh, that's a great sound.
3, 2, 1. Give it a yank.
That reduced the splash.
It did?
It did reduce the
You
splash.
say with water on your face.
Not exactly. Didn't seem much different from the first one, to tell you the truth.
Okay.
We need to focus in on the primary splash, and unfortunately this is happening so quickly that we really can't see it with the naked eye. Is there a change? I don't know yet. We're going to have to wait until we see video footage.
We've painted the USO with hydrophilic coating, and hopefully that'll create a smaller splash. 3, 2, 1.
I really saw a splash, an entry splash, but it was that secondary splash, the final one, that's making
That's the one that makes us all wet, isn't it?
They never touch the water because in front of the machine they open a vacuum space, and there is a kind of shield belt around the USO.
If we're talking about can something enter the water without a splash at all, I think it would probably have to be a different shape.
Unless the object itself was enclosed in a visually invisible to the light spectrum wave, and it's the wave that's changing shape.
Both Bill and Maximilian have an interesting theory about USOs where they create some sort of force field that surrounds them that prevents a splash from being made when they enter the water. Well, we don't have the technology to test something like that. I'd like to focus on what we did test. I think we should analyze the high-speed video.
Okay, so let's look at this control frame first. And what we're looking for is we want to kind of count how many squares it went up.
Let me see.
Just the primary splash, though, not the secondary one.
Yeah, exactly. Okay, the splash, when it's pretty thick, okay, and it's not a whole bunch of individual little droplets you would never see unless you're right there. Okay, it's only going up about 2 squares.
Now, squares, is that a scientific measurement?
Absolutely.
Yeah, okay, good. 2 or 3 squares.
So let's look at the air pressure one we did. So this one looks like about 3 squares. Okay, so it's not much different than the first one. So now let's look at the hydrophilic one. Once again, it's going up 2 or 3 squares.
Top of the 4th.
Wow, it's going up even higher, isn't it? Yeah, so that didn't help at all. Made it worse.
It's kind of ironic that all the changes that we made in an attempt to minimize the splash on our model USO actually made the splashes bigger. It's obvious that we don't currently possess a technology to make a splashless craft.